Hello everyone. Here we are going to discuss about the next topic from the subject of theory of motion 2. The topic is minimum number of teeth in order to avoid the interference. So for that I have constructed one figure over here. So here is the gear 1, center of gear 1 is O1, center of gear 2 is O2. Omega 1 is the angular velocity of gear 1 rotated in clockwise direction, and omega 2 is angular velocity of gear 2 rotated in anti-clockwise direction because they are externally meshed with each other. Now this dotted line represent the pitch circle of gear 1. Similarly, this dotted circle represent pitch circle of gear 2. Meeting at one point, that point is nothing but the pitch point denoted by P. Then this green one is the base circle of gear 1 and this green is base circle of gear 2. Now Mn is the common normal and which is tangent to the base circle passing from the pitch point. And here we have the tangent passing from the pitch point. So angle between common normal and tangent is nothing but the pressure angle. So this angle is denoted by phi. Now as you can see, we are taking the addendum of gear 1, which is the maximum one, because the addendum circle is passes from this point N. The N is the point of tangency or interference point. Similarly, addendum of gear 2 passing from the point 1, which is again the maximum addendum because it is passes from the point of tangency or interference point M. Now above this, if we are increasing the addendum more than this, there will be interference. So this is the maximum limiting addendum for gear 1. Again, this is maximum addendum for gear 2. So let us consider RA is the addendum radius of gear 2, capital RA. Small RA is the addendum radius of gear 1. And R is the small r is the pitch circle radius of gear 1. Capital R is the pitch circle radius of gear 2. Now to find out the equation for minimum number of teeth in order to avoid interference, join this O2 with M and see the triangle O2PM. Now see this triangle carefully. See this angle O2P with this common tangent is 90 degree, and this is the phi angle between common tangent and common normal. So this angle become 90 plus phi. So here we reconstruct this triangle O2PM. This angle is 90 plus phi. Let us say this is C, this is A, and this is B. So by using of cosine rule, in triangle O2PM, by cosine rule, we can write C square is equal to A square plus B square minus of 2AB cos of this angle 90 plus phi. So instead of that, we'll put the length O2M square is equal to PM square plus O2P square minus of 2 O2P PM into cos of 90 plus phi. Okay, so O2M. Now see this figure. In this figure, O2M is what? Maximum addendum radius. So let's continue this equation. O2M, keep it as it is. It is maximum addendum radius PM. See, PM is this. Now see this triangle carefully. This angle is phi, as we know. So PM is O1P sine of phi. So PM is O1P sine of phi bracket square. Then O2P. O2P is pitch circle radius of gear 2. So it is R square minus of, again 2 into O2P is R into O1P sine of phi. PM is O1P sine of phi into cos of 90 plus phi. Okay. Again O2M square as it is. Now see, O1P is what? Small r. So here we write small r square sine square phi. O1P is small r, so small r square sine square phi plus r square minus of again 2 into O1P is small r, this is capital R, and sine of phi into cos of 90 plus phi means minus sine phi. Okay, so r square sine square phi plus r square minus 2r capital R. So this minus minus become plus sine square phi. Now see these two terms. Here we have the sine square pi. So let's take that common. So let me write this r square over here plus r square, this small r square plus 2r sine square phi. So let's continue. Let's take this r square common, capital R square. So capital R square into bracket, here it is 1 plus, now into bracket r square divided by r square. Okay, because we are taking this r square common, plus 2 small r, 1 capital R get cancelled, so remaining is 1, only 1, into sine square phi. Okay, so O2M, it is O2M square. Now let's take square root, so it is O2M, this r square become r into bracket under root of 1 plus r square divided by capital R square plus 2r upon capital R sine square phi. Bracket close. Now as we discussed, O2M is the limiting radius of addendum circle in order to avoid the interference. So when we are going to discuss about the addendum, that is radial distance of from pitch circle to the addendum circle, addendum of gear AW, so it become O2M minus of O2P. So this addendum is maximum addendum. So let me write here maximum. It is equal to O2M minus of O2P. So we know that what is O2M? It is R into bracket under root of 1 minus 1 plus R square upon capital R square plus 2R upon capital R into sine square phi. O2P is the pitch circle radius of gear 2, so it is R. So let's put minus of R outside the root. Again let's take this R common from two terms. So R into bracket under root of 1 plus R square capital R square plus 2R divided by capital R sine square phi minus 1, and now close the bracket. Okay, so we have AW max. So instead of now this R, we can put M capital T by 2 into bracket. Now 1 plus, now see this term carefully, again from this term we can able to take common small r upon capital R. So let's take common this term small r upon capital R into bracket small r upon capital R plus 2 sine square phi outside the root inside the bracket minus 1. But we know that, see, addendum is equal to AW into module. So AW is addendum coefficient. See, we can say that addendum is equal to 1 module. It is 1 is AW, so it is addendum coefficient. So AW is addendum coefficient, M is the module. So instead of this AW, we can put this value. Okay, so let me write that equation. AWM is equal to MT by 2 into bracket root of 1 plus R upon capital R into bracket R upon capital R plus 2 sine square phi minus 1 bracket close. Okay, so again this M get cancelled, so what remains is AW is equal to T upon 2 1 plus R upon R small r upon capital R plus 2 sine square phi minus of 1, close the bracket. Let's shift this T on another side. So T is equal to 2AW divided by this whole bracket, that is under root of 1 plus R upon R upon R plus 2 sine square phi is inside the root and minus 1 is outside the root. This is the limiting value of number of teeth, or we can say that this is the equation for minimum number of teeth to avoid the interference. So let's write this equation in another way. So it is 2AW divided by under root of 1 plus, now this instead of this R upon R we can put small t upon capital T sine square phi minus of 1, that is instead of this R we'll put mt by 2. Similarly mt by 2, mm and 2 get cancelled, so what remains is small t upon capital T. Now see, this is the equation for minimum number of teeth to avoid the interference of wheel. So let's put, instead of T upon T ratio we can put the symbol of gear ratio. So it is 2AW under root of, now what is T upon T? It is gear ratio, but it is inverse of gear ratio, so we will put 1 upon G plus 2 sine square phi minus 1. Okay, now we know if addendum is equal to 1 module, so this 1 become AW, so number of teeth is equal to, now instead of AW we'll put just 1, so it become 2 upon under root of 1 plus 1 upon G plus 2 sine square phi, all is inside root, minus 1 is outside the root. When two gears are similar, gear ratio is equal to 1. In that case, number of teeth become 2 upon under root of 1 plus this 1 upon G become 1. So it is 1 plus 2 sine square phi minus 1. So it is 2 upon 1 plus 3 sine square phi minus 1. This is the equation when gear ratio is equal to 1. Similarly, when we consider pressure angle is equal to 20 degree, let's put that value 20 degree over here. We'll get minimum number of teeth is approximately equal to 13. Now similar way we can able to calculate minimum number of teeth for pinion. So instead of AW we'll put AP. It is equal to, now here is AW is equal to capital R 1 plus small r square divided by capital R square plus 2 small r divided by capital R sin square 5 minus of 1. So for AP it become, instead of this capital R it become a small r. Similarly we going to change over here. So let me write that equation. Small r under root of 1 plus capital R by small r, capital R by small r plus 2 sin square phi, remaining equation as it is, minus 1. We can able to prove this equation using of this construction. That is, when we join this n to O1 and consider the triangle O1PN, we get this equation. So again let's simplify this. It become AP small t is equal to, AP into M is equal to by 2 under root of 1 plus sin square phi minus of 1. Okay, again get cancelled. So what remains is AP is equal to T by 2 under root of 1 plus capital R upon R plus 2 sin square phi outside the root minus 1. So small t is equal to 2 AP. Let's take this term here and this term is going to dividation. Okay, so this is the equation for minimum number of teeth in order to avoid the interference for pinion. Like here we can simplify this equation to AP divided by under root of 1 plus, now R upon R become T upon small t, T upon small t plus 2 sin square phi outside the root minus 1. Similarly, now instead of this T upon T we'll put G, so it is 1 plus G plus 2 sin square phi minus 1. I hope you get the concept and how to solve or how to get the minimum number of teeth in order to avoid the interference. So we'll stop here. Thank you.